So in this circuit we have these resistors connected to the switch, and these resistors are actually pulled up via this black line which is connected to VCC at this location. These resistors are connected to one end of the switch. Each switch other end is going to the grounding, and the center point at the joining of resistor and switch is given to pin numbers 5, 6 and 7 of your Arduino Atmega 8 board. So whenever you press a switch, it's logic 0. If you release, it's logic 1 for all the 3 switches. Since all the pins of Atmega 8 are internally pulled up, that's why this external pull up is just for increasing the current, and switch pressing will short it, and all the voltage drop will be across these resistors of 8.2K. Then we have 2 LEDs whose anodes are pulled up to VCC point, and their cathodes are given as a output to the pin number 8 and 9. So whenever you send a logic low to pin number 8 or 9, the LED will glow, otherwise LED will remain off. And initially all the pins of Atmega are logic high because of their internal pull-up. That's why LED will remain high. And also we have programmed it to be high so that there will not be any false triggering of LED due to floating point voltage. We have a current limiting resistor of brown, that is 110, and the second is also brown. Okay, so one is 110 and other is 1K. So then we have those are to limit the intensity. Then we have to connect the ground of our DSO at this point. Now this point will give us the output, that is ground at this, and pin number 3 is output ECG signal. Now whenever output starts, you just connect the DSO between them. You should get your heart wave simulated waveform. So this is a basically ECG simulator circuit. तो आपको जो करेक्ट सिमुलेशन आउटपुट वेवफॉर्म आएगा उसका स्पीड जो है उस पर एरर इन द हार्ट रेट पता चलते हैं. तो 3 टाइप के हम लोग ने हार्ट मेजरमेंट किए. फॉर नॉर्मल वी हैव यूज दिस सिग्नल, फॉर फास्टर एंड फॉर स्लोअर. सो डॉक्टर हु इज अंडर टेस्ट, ये एग्ज़ाम देने आए हैं, उसको ये ECG वेवफॉर्म दिखेगा और उसको गेस करने को बोलेंगे कि करेक्ट वेवफॉर्म है, फास्ट वेवफॉर्म है या स्लो वेवफॉर्म है. He will press the switch accordingly. If the answer is correct, the green LED will glow, and if answer is wrong, red LED will glow. And this Atmega 8 IC is having 8 KB of internal ROM. It is connected to 16 MHz crystal. We are following Arduino Uno standard open source hardware in which you can program your IC with Atmega 8L, but currently this IC is not working, so we have directly programmed it. Then we have external supply connected it. We have the this is 7805 regulator which will convert the external supply of 9 volt, and this is FTDI chip with USB to RS-232 converter. Then we have 3.3 volt regulator supply, that is a voltage divider bias put, and pin number 13 is at output LED pin. And we have ICPH header which is used for in-system programming, but currently we are not using that. We are just removing the IC and programming it via other programmer and then putting it. But ideally this should program it automatically. So when you connect a USB at this point, the Arduino software you just have to load, and then you have to click on burn. The entire system will be burned, and the internal hex file is burnt onto this chip, and then your chip should start running. Now whenever you set a wrong result, you can just press this reset button to reset your system, and again it will start generating a ECG waveform. Now we have internally designed the ECG waveform to be 100 times. After 100 time repetition it will change, and during doctor doesn't know when it will change, and he has to press the correct button at the correct time. Then only his answer will be correct. So this is basically a testing of a doctor, how he can judge a ECG waveform via a ECG simulator circuit.